FastMCP 3 implements a pipeline-based transformation system where components flow through configurable filters before reaching clients. This design employs the middleware pattern for individual component retrieval and pure function processing for sequence-based operations, enabling flexible modification of tools, resources, and prompts at both provider and server levels. We're about to examine how server mounting establishes provider relationships while applying namespace prefixes and tool transformations to incoming components. The code will demonstrate chaining these operations through the mount, method, and subsequent transform registration, showing how component names and schemas get modified in the pipeline before client exposure.
Main equals FastMCP main. Mount equals main. Mount subserver namespace equals API. Mount add transform tool transform.
This code demonstrates server mounting and transform chaining in FastMCP 3, a pattern for composing modular servers while maintaining clean component isolation. The mount operation creates a provider-level namespace boundary, prefixing all component names from the mounted server with API to prevent naming collisions. This is more maintainable than manual namespacing, as it centralizes the isolation logic in the mounting operation rather than requiring each component to declare its namespace. The transform chain shows FastMCP's pipeline architecture in action, where components flow through sequential modifications. Here, tool transform is added to the mounted provider, meaning it will process components after the namespace transformation. This ordering is intentional provider-level transforms like this one run before server-level transforms, giving you fine-grained control over component flows from specific sources. The pattern enables clean separation of concerns. The mounted server focuses on its core functionality, while the main server handles cross-cutting concerns like naming conventions and tool schema modifications. The approach trades some runtime overhead for significant development flexibility. Each transform adds a small processing cost during component lookup, but this is typically negligible compared to the benefits of modular composition. The pattern becomes particularly valuable in microservice architectures, where you need to aggregate multiple specialized servers under a unified API surface, while still allowing each to evolve independently. The namespace transform handles the isolation automatically, while the tool transform provides a clean extension point for customizing exposed functionality without modifying the original server code. Let's break it down line by line.
Main equals FastMCP main.
Creates a FastMCP server instance labeled main for identification in MCP protocol handshakes. The string parameter serves only as a server identifier visible to clients during connection establishment, with no functional impact on server behavior or configuration.
Mount equals main. Mount subserver namespace equals API.
Mounts the subserver onto the main server with a namespace prefix of API. This operation makes all components from subserver available under the API namespace, preventing naming conflicts with other mounted servers. Tools and prompts from subserver will be prefixed with API, while resources and templates will have API/ added to their URI paths.
Mount add transform tool transform.
Adds a tool transform to the mount objects transform chain. The tool transform is configured with a dictionary of transformation rules represented by. That will modify tool schemas as they flow through the server. This transform will apply to all tools from the mounted provider, allowing renaming, reshaping of arguments, or other schema modifications before the tools reach clients. The three lines work together to create a modular, isolated component pipeline in FastMCP 3. First, the main server instance establishes the base system. Then mounting the subserver with the API, namespace automatically prefixes all its components, creating clean isolation without manual naming adjustments. Finally, adding the tool transform to the mount applies schema modifications specifically to tools from that provider, demonstrating the pipeline sequential processing where namespace transformations happen before tool-specific modifications. This composition pattern enables independent evolution of mounted servers while maintaining unified API surfaces, with the small trade-off of transform processing overhead for significant development flexibility. The key insight is that provider-level transforms like tool transform run before server-level transforms, giving you precise control over component flows from specific sources while maintaining clean separation of concerns.
The namespace wraps the tool in darkness, but the client summons it by whispering its name.